All right, good morning. Just real quick, we'll do a quick introductions. My name is Jaime Franklin. I'm with Palo Alto Networks. I'm the worldwide cloud architect. I lead all of our cloud consulting engineers across the globe. And with me, I have Itai. You want to introduce yourself?
Sure. My name is Itai. I run the SecOps team, Security Operations CE team. We were formerly in the threat team, so our expertise are more in the way of cybersecurity, threat intelligence, and we have decided to actually start do a little bit of working together in terms of merging the two fields together, the threat intelligence and how it applies to the cloud, security best practices and things like that.
So for this session, we're gonna dive into from an architecture perspective and from a security perspective, because most times as we talk about public cloud, a lot of times we end up talking about architecture, and a lot of times security ends up being an afterthought in a lot of our conversations. And as you look at where we're going and where cloud is going, the enablement of applications and services is key to is the key delivery of why we're doing public cloud. So how we can harden those applications and provide security. We're going to address some of the things that we hear, with native security tools. Native security tools are enough. So we'll address some of those things. We're going to talk about an inbound internet-facing application, which is one of the probably most common high-level architectures that we are usually talking to customers about. We're going to give some examples of some architectures around that and give you some recommendations and why we make those recommendations. And then we'll dive in and talk a little bit about the native tools and how it can mesh with our with the Palo Alto platform. Because as you look at security, analytics becomes very, very key, as you've heard through the different sessions that you've been to this week. Analytics is becoming security. The data that we have, the ability to be able to correlate that data, that is a critical piece to security. And so as we look at those native tools and being able to bring in the analytics from those native tools to be able to utilize them in our security stack, in our platform, become important pieces. So we'll talk a little bit about some of those native tools. We're going to mainly focus on the AWS side, but we have similar things just from a timing-wise. We have similar things in Azure and in GCP, Google Cloud, that we can do as well, but we're going to kind of focus on AWS today. So with that, so everybody is very familiar with AWS's shared security model. And as you look at the shared security model, AWS is responsible for and build their SLAs based on their fabric. So the hardware pieces to what we are then tied into, all of that is the responsibility of the cloud provider. The cloud provider is expecting that you are going to actually take your applications and that you are responsible for your applications. They give you some high-level tools, which we call native security tools, to be able to help with some basic security. But if you talk to them, most times they'll tell you that those basic tools are very basic. They're not meant to be enterprise-level security. And that's where you as a customer and us as Palo Alto have to come in and look at your applications and build a comprehensive security posture for your environment. So as we look at that, what that means is, as we look at coming in with a customer, the ability to look at and identify risk becomes one of the most important aspects to looking at each application. We have these macro-level architectures. When I say macro-level architecture, what we're talking about is you as a company have to become a service provider for public cloud to your own organization. You've got to set those parameters around how cloud is going to be consumed within your organization. You have to take care of high-level things like how you're going to federate your user base, you're going to manage your accounts, how you're going to handle ingress, egress internet, how you're going to handle things like, am I going to have traffic that will go VPC to VPC or VNet to VNet? Am I going to have hybrid cloud? How am I going to set segmentation up for hybrid cloud? These are high-level examples for use cases that from a macro level have to be decided upon. Once you have that macro level architecture, then you can dive into the, what we'll be talking about today from an architecture perspective. You can dive into, looking at each application, because when you build that application and you build the security piece to that, it becomes very important for you to be able to take a look at risk, because risk is going to lead you to what security services you're going to build into your application to secure your application. And then we're going to validate that with analytics to make sure that you're meeting the risk goal that you set for that application. And analytics, as we start analyzing analytics, we then have the ability to, from what we're learning from the analytics, we can actually adapt and change posture to be able to adapt to threats that are happening, and it's this continuous cycle. So then we can evaluate risk as we're seeing things and go back into that loop. And we'll talk a little bit more about some of the security cycles that we see from a risk compliance perspective. Go ahead.
All right. So as you can see on these slides, we don't usually provide the prettiest slides of them all, but I think when you're looking at security as a whole, it's all about the cycle and closing the loop. Security is not trying to equalize an equation. It is a continuum, and it should be always continuous and a continuous process. When we look at security, you can see when it goes to tools and analytics, and then the IR, the incident response. And each and every part of this component needs to be all the time, that loop needs to be all the time closed. There needs to be a feedback loop. That feedback loop needs to be at all times addressed. There needs to be some kind of an outcome. There needs to be some kind of a process. If you take at the top of the equation here, or the top of the paradigm here, when you're talking about governance and risk, really this is driving everything. We're not going to dive more into the intelligence or into the techniques of how things are done, how things are being hijacked in the cloud, or how code is being used, but really on the high level of how to address those types of processes across the platform, and where we augment an existing security infrastructure that a cloud provider might also offer. So it's all about what they have and how we augment what they have with a better process to close those feedback loops. Usually cloud providers see security or look at security at a very, I will not say a myopic way, but a very specific way that addresses their needs in terms of how they provide the services to everybody. But then again, when you have your own infrastructure and you have your own deployment, there are risks that are associated with what you have. If those are databases, if those are servers, the objectives of every hacker group or every campaign is really take advantage and try and get into your infrastructure, try to harvest credentials or use already harvested credentials, and then laterally move across your infrastructure, whether it's a cloud, whether it's not a cloud, and try and take advantage and steal that data or use that data or breach it in any way that they can. So in terms of, as you can see, the things that we are augmenting here goes across the board of specifically here, the Amazon infrastructure. So the same thing if you're going into the console and then into the storage and then the infrastructure and the endpoint, you can see the various components within that puzzle of what that particular cloud provider will give you, and what we will give you as well as on top of it, because there are some gaps there, and those gaps needs to be tightened and closed. Again, so when you're talking about governance and risk, is really assessing where a breach might happen, where a vulnerability or an existing vulnerability might be exploited. It can be a Drupal, it can be a SQL injection, it can be on a server, a regular server that you're hosting in your facility, and it can be the same server that is going to be on the cloud. There are some rules and some laws, the same laws of exploitation still exist. and you need to address those things, especially if it's something that's it's in the endpoint and it's becoming what we would call sort of like an EDR type of a situation. The same thing would exist in that infrastructure, or even if it's a hybrid infrastructure. And think about customers and organizations that move more and more towards having more than one cloud provider. You can have a provider that you use for some things for Amazon, and then for some other things that you use on Google, and some other things that you use on Microsoft. How do you federate those users? How this data stays protected? What happens if there is a breach and one service is compromised, let's say internally, and then you're able to go into those cloud instances and do damage in those cloud instances? How do you have the ability to trace that? How can I find all the things that I need in order to fix that problem and to see where the gaps took place? What do I need to do in terms of as a response? So again, it's a kind of a feedback loop, but it need to cover your bases in that way.
All right, so we're going to spend a little bit of time and dive into some architecture. So as I said before, we want to cover we want to cover that internet-facing application. So exposing an application, web-based application for or utilizing cloud as the delivery mechanism. So as we look at where we started from, as we look at the VM series and an inline posture, the first thing that we always have to address is what's the insertion model? How do we insert that into an architecture so that we have a way to be able to flow the packets through our firewall so that we have visibility to them, so that we can apply policy to them and give you the rich context that we bring with our layer 7 visibility. And early on, as we started looking at the firewall with multiple interfaces and given some of the routing the transitive routing nature of AWS, it became a little bit difficult to be able to look at and insert our firewalls into these environments. So changing gateways and doing things like that so that we could push and specifically point traffic to our firewalls, and the scaling pieces were very difficult as we did that. So things have evolved with regard to architecture, where we're looking at now utilizing load balancers, and with load balancers now, having flows that are coming through the load balancer so that we can scale in on the back end and do the horizontal scale for public cloud to make the applications so that they can actually handle larger amounts of traffic, make them redundant, and give them some of that functionality. So as we look at that environment, one of the things that I've seen is customers are moving to these environments, but as they move to these environments, they're taking and building multiple applications and trying to standardize on a smaller set of hardware and expanding and doing multiple applications, which obviously it works. And so as we look at, what are the best recommendations as you guys are building these? If you're going to take and use an environment and have multiple applications in that environment, it's not one of our recommended architectures for the simple reasons that as you build out an environment like that, as you build out multiple applications, as you update code, as you do patching and you do those types of things, using common architecture, if I make a mistake or something happens or breaks something, I'm going to have a much wider outage where it's going to impact multiple applications. So for those reasons, we look at trying to isolate each of the applications and building out an environment for that application. And so, again, I'm not saying you can't do this. I'm just saying it's not a recommended way of doing things, and we'll talk about the recommended here in a bit. One of the other architectures that we see a lot and talk about a lot, whether it's Google, Azure, or AWS, is the transit model, so transit VPC in AWS. It's been kind of neat because, as we started hearing from AWS and hearing from a lot of our customers, it's pretty amazing. I mean, this architecture solves everybody's needs, right? It's become so common that a lot of architects are leading with the transit VPC architecture. So, first thing, as we look at architectures in cloud, when you have use cases, taking multiple use cases and trying to use the same architecture for multiple use cases is typically a bad thing. And so as we look at this architecture, people see this as a way that I can bring in my inbound traffic for an inbound-facing internet application, as well as use this same architecture to be able to handle outbound traffic so that I can centralize and send outbound traffic. Well, as we look at this, you know, it's not a recommended architecture for an inbound internet application, because what you'll find, and as I deal with customers and travel and talk to customers, it's a good place to start. This is a very easy way for them to start. There's a lot of automation templates that have been built around this. But what I find is they get very frustrated very quickly, because as you look at some of the limitations that you face. So in the spoke VPCs, I have two options where I can use the VGW and create my IPsec overlay, or I can use another instance like our firewall and have multiple firewalls where I can create multiple VPN tunnels, IPsec tunnels, you know, and you have different complexities there. So if I use another instance, how do I handle the high availability if I have multiple availability zones and I lose one of the firewalls? I have to have a Lambda function of some sort that can actually identify that, make a change to my route table so that I can route all of my traffic through the other firewall and out through that IPsec tunnel. It just adds complexity. You can do it, definitely do it, but it just adds complexity. If we use the VGW, I get the ability now to span across the availability zones and have multiple tunnels that are built with each of the VPN connections, and I can peer that into multiple firewalls in the hub and get some high availability. But then I run into issues like, I think right now the VGW can do 1.25 gig max of throughput through the VGW. So as you start looking at that and building multiple applications, and you know, it becomes a bit of a challenge for you. So what I'm trying to drive at with regard to the transit VPC architecture is, it is a good architecture, but as you start to grow and scale, you become very, very limited in what you can do with the architecture and the complexity that will go into, you know, how do you get to the point where I've oversubscribed the firewalls that I have in my separate availability zones in my hub or my transit VPC, and I need a second hub, or how do I manage that third hub? It becomes very big, very unwieldy, and it becomes, from an operational perspective, very difficult to manage. So for those reasons, you know, as we look at the transit VPC architecture, it becomes a recommended architecture for us for an outbound use case, because for us to take and build a transit hub where we have multiple firewalls, where I can now automate delivery of security feeds, centralize my security feeds, my black holing of DNS, you know, my whitelisting, blacklisting, gives me a centralized place where I can build that posture, have everything go through there, as well as give me a connectivity point back to my hybrid cloud environment. So for an outbound use case, it definitely works, but for an inbound like we're talking about, it's not a recommended architecture for us. So let's talk about the recommended architecture. What I've seen with customers, you know, is early on in their cloud maturity, they've done the things like transit VPC, they've done multiple applications and had these big, huge VPCs. And what I've seen them do is pull back on that. I've seen them pull back and say, this is too complex, this is very difficult for us to manage. It's hard to turn over to my SOC, to my operations team. And so what we see them do is look at and try to pull back and take these environments and simplify them. Because when you look at cloud, the automation aspect to cloud and being able to manage and scale based on automation becomes very, very important as you grow and mature in your cloud journey. And so one of the things that we recommend is simplifying down your architecture to a very simple form, making that be a common scale point, a building block, if you will, that you can then use. Because as you look at an environment like what we're showing here, it's very basic. You know, I've got a load balancer on the outside, or I don't have to use the load balancer. I can go directly to a firewall. I can build these small, consumable VPCs and VNets, where I can now, through global load balancing, whether it's Route 53, global DNS, other services, I can now actually use that to be able to load balance across the different, my different small VPCs. I also have the ability, because of the portability of these, that if I wanted to, I can actually spread and automate the delivery of the same objects or the same VPCs into multiple cloud providers. And again, through global load balancing, I can manage and distribute those. So we'll look at what that looks like. So from a single VPC in AWS, we typically recommend for web applications that we use the ALB on the front end. And the reason for that is our firewall can do the SSL termination, but it creates overhead on our firewall. So can we do it? Yes, we can design that in. When you look at the ALB in AWS or the application gateway in Azure, they're built to be able to handle that SSL termination. So we'll use those devices to do the SSL termination and then send the packets to us, where we can then analyze and apply policy to those packets. And it gives us, so having active, high availability, the scale piece behind a load balancer is really the cloud way of doing that. If some customers ask about, instead of using the load balancer, can I do an active passive? When you look at high availability in the cloud, doing an active passive in session sync and having that legacy data center mindset and moving that into the cloud, you can do it, especially in AWS. We support that as a feature. But what happens is we have an interface on the fabric and an interface on our instance that are married together. If I want to move to my passive, I have to issue an API command to decouple those, move that interface to the passive, and while I'm doing that, I'm black holing traffic. And depending on what's happening in the fabric, it can take up to 2 minutes for that to happen, and I'm going to drop all of my TCP sessions anyway that I've synced across. So it's not a very cloud-friendly way of doing it. So that's why we see the load balancer, where we can terminate the SSL, and then it will help us manage so that we can scale out firewalls behind the load balancer. And there are things that we can do so that we can keep source and be able to view source address coming through the load balancer, so that we still get a lot of the rich context around what we're seeing from a layer 7 perspective. So that model becomes our scale point. So we look at this now from a single region, and I'll see customers that, do I do multiple firewalls in a single VPC, or I want high availability with different availability zones so that you're getting different data centers? And what I'll see is a small block with a single firewall, and you build the same block in 2 different availability zones, and then I can load balance across those with Route 53 in AWS. You're getting the same benefit of it being in a single VPC and having multiple firewalls behind the load balancer. So it's kind of your choice. You can keep it that simple, or we can do multiple VPC or multiple availability zones in a VPC, where we have the external load balancer that through the external load balancer will load balance across the different availability zones. So, and we also have where now I can take and across different regions. So if I want, US West 1 and a European data center where I have my same application, again, through global load balancing, I can take that same consumable building block and deliver those and automate those for delivery into different regions and use global load balancing to be able to load balance across those different regions for my application to give me the redundancy that I need for my applications. So this is something that I'm seeing a lot of customers start to really migrate to, because it gives them the smaller points to be able to scale from, and how they're starting to look at delivery of applications rather than these big, huge, complex architectures just from an operational perspective. So I can talk about this for many hours and go through this. I'm happy to answer questions if you have any questions. We'll leave some time at the end of this, or even after that, we'll spend some time at the back of the room. But just quickly wanted to go through, kind of some common architectures that we see, and then talk about what we recommend and why we recommend it. So as we look at cloud has created a lot of new things for us. So being an old networking guy and dealing with routing and trying to understand routing, UDRs in Azure kind of blew my mind because they break every single routing rule that we ever learned in our private data centers. And so one of the things that has been created through public cloud is the need now for, as you look at public cloud, each provider is kind of like a black box. And I think as I talk to customers, I think the two biggest things that have been consistent over the 3.5 years that I've been at Palo Alto Networks, talking to customers about public cloud, has always been customers are worried about visualization, because with the black box and what's going on in the fabric, trying to get the visibility into that is very difficult. And so that visualization into security, and that second one is security. So visualization into security, visualization into my environment, and what are the tool sets that I have so that I can actually turn that over to my operations team for them to use. Those end up becoming big challenges for a lot of our customers that are moving to cloud. So as you've seen recently, we acquired a company called Evident, and we've made some other news with some other acquisition targets that we're making in attacking the API-based visibility sector. So the API-based visibility sector really ties into, and we kind of show this from a building block perspective, the console, and managing users, roles, making sure they're set up correctly, and securing the console and access to resources and deployment of resources. It gives us the ability from a storage perspective. This is a huge differentiator. Like when you look at breaches that have been reported, most of the breaches that we see in public cloud are related to global storage. So with our Evident storage, we have the ability now to be able to tie in and give you that DLP functionality so that we can actually make sure that your S3 buckets are actually secure, as well as looking at the data that's coming out of them, that we can do match patterns so that we can actually provide DLP functionality out of your global storage. It's not just AWS, we can do that in Azure storage as well as Google. So the API-based visibility that we gain gives us those capabilities for storage. And then last but not least, as we're deploying devices, some of you may have sat through Eric Youngin's session where he did an attack where somebody went out to the marketplace, deployed an instance. The instance had vulnerabilities in it. Our ability from an infrastructure perspective with our API-based visibility gives you guys the ability to be able to set minimum or maximum standards for the different the AMIs that you would be delivering out of marketplace, so that you can make sure and put some enforcement points around not allowing people to deploy AMI instances that have known vulnerabilities. So as we look at that architecture piece, the Evident tool sets will give you visibility into your marketplace and into those AMIs to be able to provide you some security and some function to be able to limit what and who can do what from a deployment perspective. So as we look at Evident, Evident is a very easy tool for us to be able to deliver. It is a SaaS-based tool. It runs in cloud. You have the ability to set up the API keys, associate your API keys, and then you're going to get a consistent monitoring of your environment. And so we will be able to provide you reporting. We'll be able to give you compliance reporting so that, as you need to, for audit purposes, generate visibility into your cloud and your cloud environments. Our Evident tool can give you those tool sets that you can match to specific compliancy reporting. So for those of you that aren't familiar with Evident or haven't spent much time with it, I definitely highly recommend, setting up a demo, going through and let it see what it sees in your environment. How are your security groups configured? Do you have any holes? And it can do that very quickly for you and give you some very valuable, vital information for your environment.
All right. So expanding from what was said by Jaime here, let's talk about what happens actually when an instance is being compromised, when an application is being compromised. And again, we need to go back and see how well we are able to discover that something like this had happened. And in that case, if something like this was happen, how we're going to mitigate and what we're going to do about that particular thing, how we're going to configure our infrastructure to be able to discover those types of things. As again, we're talking about a feedback loop, and in a feedback loop, there's things that happens during the attack or even post-fact. Let's say that we didn't know that there's a particular vulnerability. Vulnerability was discovered after deployment, and then there are attacks or actually an exploitation that's actually happening in the wild. So again, how do you go back? How do you actually do analysis? How do you do forensics? And then how can you see on your console and in your infrastructure that something like this is actually taking place? So as you can see, in terms of infrastructure, there's a lot of tools that will help you mitigate that. We're going to talk a little bit about the VM series as well, but you can see here a very good list. Again, one of the main objectives when a breach and when an attack has happened is really credentials and identity. This is the most prolific thing as when you're crafting an exploit, and when an exploit is happening. Part of its life cycle, parts of its existence, is the ability to advance, is the ability to reach the objectives. And in terms of reaching the objectives, you have to go through harvesting users. So either you'll do it, and there are a lot of cases where we were seeing a lot of exploitations that happen in the wild where harvesting is happening actually beforehand, and then you obtain, or a particular player or hacker obtains credentials for a particular instance or a particular user in an organization, and use those particular credentials to log into the instances and do its thing. So how do you know whether a user is being compromised or credentials have been used natively by someone from the outside who happened to have access and got into the system? Those are the big questions, and those are the really where the rubber hits the road. A lot of times there are a lot of vulnerabilities or exploitations that actually look at the API itself and how you can interject with the API. As much as it would be trivial to do something like a SQL injection or things like that, how do you protect that? How do you make sure that your instances are protected if there is any exploitation? How do you close that feedback loop of patching that exploitation and making sure it will not happen? What do you do in your environment, for instance, to see if something like this is happening across the board?
Before you move from that, I just want to also add to the IAM piece. Earlier I mentioned that federation of your user base. When you look at IAM becomes the way that you actually would federate that user base into AWS, or IAM is used in Google Cloud as well, or Azure Active Directory. You know, one of the things that I see customers do is a lot of times they skip that portion of how they're going to manage that, what it's going to look like, how they're going to define their roles. And as they start to scale, that becomes an issue. And so as you look at, and I'm guilty of this myself, I did an auto commit and it pushed some of my API keys up to GitHub, and within a couple of minutes I pulled them down, but somebody had already gathered those keys and actually deployed into every single region in AWS. So it's a big deal with how you manage your API keys, how you secure your API keys, because it can cost lots of money. And so how you build out that federation, how you're going to set up your accounts, how you're going to manage those keys and rotate the keys and those types of things. These are all strategies that very early on in your cloud journey, you have to be able to address those pieces and have a plan for how you're going to manage that and set that up, because as you do that in one cloud, if you move to a second cloud, you're going to have to do the exact same function in a different form, but very similar in structure. So it makes it very important for you to define that up front and early. Go ahead. I thought this is you. No, that's yours. Okay. So as we look at a lot of times when we talk to customers, everybody kind of looks at and talks about security groups and network access control lists and kind of view them as the same thing. But there are some major differences between the security groups and the NACLs. You know, when you look at, you know, the security groups support allow-only rules, and in the NACLs you can do an allow or a deny, and you get more of a stateful function from the security group versus network access control lists are stateless. So I think it's good, you know, as we start talking about these concepts from a native tool set to understand the differences between them.
Another good statistics that was one of the Verizon breach report. About more than 60% of the attacks or the breaches that takes place utilizing credentials that were stolen from a different place. This is a very interesting, there's a whole market, there's a whole world around credential harvesting, data dumps. You can go to the dark web, you can purchase entire databases for customers, for organizations, for banks, for a lot of things. And a lot of times the various places in the attack, in the breach, the exfiltration, the entry point, usually happen within already either a pwn user, a user that was these credentials were either stolen in other methodology, either through phishing or other things, or through a data dump. So an attack that was made took advantage of an existing user, credentials were harvested, and then the entry point started to get in and go around. Back here, as you can see, going into our platform, a lot of times the logging is disabled by default, so it's very, very important actually to enable that and start the logging process. Again, the more logging, the more data that you are able to obtain through our platform, it'll give you a better visibility into what's going on in your deployment and into your cloud. So would be the first recommendation is turn the logging on and start logging data. And I'm going to run through a little bit forward and to see why those things are so important. Another thing in the logging caveats, as you can see, for instance, what is happening here with the skip data. It's very important to know when the skip data happens. And I actually have seen an example, I read an example where a particular denial of service attack happens against a particular instance, a particular customer, where they have flooded their logging. There's not enough place that was allocated, or they have DDoSed it long enough where it could not log anymore, and then the skip data came in, and when you have skip data, really, your logging mechanism pretty much falls apart. So it's very important actually to set the space and to set a lot of space in order for you to have those logs. Well, first, as you can see, if you go into the 5-tuple log, and a lot of instances, a lot of providers are using it, you can see actually the difference between the visibility of what a 5-tuple log, which is pretty much very, very default, as opposed to what we're offering as a log and contents of a log. Now, why is it so important? Because you get greater visibility. Again, we are not port protocol based. We are app based, and you can create a lot of policies just by looking at the log, at the second log type, and you can see that there's a lot more information that you can glean, especially when a situation where you need to actually comprise a timeline for an incident. You can actually go all the way to what was used, what version was used, what app was used, a lot of things on that regards. And then you can actually automate that particular policy based on those logs. So there's a lot of information that comes from here and derived from here. And then you go up into the higher level, into the entire organizational view. You can actually start deriving heuristics and statistics and analytics just based on the log. So this is why we say it's very important to turn those logging on, because you get that kind of visibility as opposed to just the 5-tuple. You get that type of view.
In each of those points that he's talking about, those become different points of enforcement that you can use in policy. And you know, to be able to get to that granular level, to be able to use that from a policy perspective, helps you harden your applications and secure your applications that you're delivering via cloud.
So if you're looking at the native application or the native protection, for instance, for Amazon, use the WAF, it is a very, very good tool, but it misses some very, very key points as well in terms of some of the logging, although it is start to log, right?
Yeah, it wasn't until very recently that AWS actually would collect logs from the WAF. So very recently, they just enabled the ability to start collecting logs from the WAF, which was a big hole there for a while where I had no visibility into what it was seeing and doing because I had no logs to be able to take a look at that. But they've fixed that very recently, which is a good thing. So now we can use that log as well as more analytics for our platform.
As well as what happens even if you're using a WAF, what happens if your environment is very, very dynamic, is very elastic. It grows, it expands, and it shrinks as time goes by. A very native or default application sometimes is not enough, as well as how you enforce very specific policies. If you want to get very granular and very specific and start enforcing app IDs and things like that, then the WAF might come a little bit short with that. Now, when you're looking about the load balancer, again, it was discussed before how you're doing the SSL termination, and then if you're actually looking at URI content, things like that, it's very important to note.
The AWS or the application load balancer gives us the flexibility because now I have the ability that I can do things based on URL. So I can pass that URL where we can actually read that from a header, and then we can build our applications and policies with custom app IDs to be able to secure those applications based on specific IP address, or not IP address, sorry, based on that FQDN. And so as we look at that, we have the flexibility to do host or path-based differentiation, which we can use and pass and secure to make sure that we add that extra layer of hardening into our applications. So I highly recommend that as you start looking at and building your applications in public cloud, that you get to that level where if we have a common app name or app identity for it now, great. If not, then we can create a custom app ID. So that way you can visualize and you know, I've gone through some attack vectors and some other sessions where, you know, we actually have taken the, because as I look at the logs and if I see things hitting my device based on an IP address, I know that somebody's profiling me, because how many of you actually surf the web by typing in IP addresses? And so most everything should be coming from an FQDN. And so as you look at public cloud, it gives you an extra layer of protection, because now within that, I can actually, if I did an NS lookup, so if I know that there's an IP address out there that I want to profile and I want to see what the domain name is, I can do an NS lookup. But when you do that, because it's a public cloud IP address, it's hidden. It'll come back with a generic name for the public cloud provider that you're in, you know, like a Google instance, something or another in Google Cloud, and they do the same things in AWS and Azure. Where that's important is now, if I do a custom app where I do an HTTP header, where I'm matching on the DNS record itself, if I try to hit that IP address, and I set it for web-based, so HTTP, I don't care about ports, I don't care about anything else. I am going to match on that header. I'm going to match on that header being a unique DNS name. And if you're not hitting that application by that DNS name, you're going to be dropped. You have no visibility to the app, no profiling that you can do to the app. It's that extra layer of hardening that we can do, and we can tie that back into the application load balancer so that we can make sure that it is tied back through there, and we can set policy there as well, that we can work in conjunction with the WAF. Or, you know, we're not a WAF, we'd never market ourselves as a WAF, but we do a lot of WAF features within our firewall that we can actually provide that functionality.
And again, a large amount of exfiltration and entry points or direct IP reference. So by doing something like that, by that kind of hardening, you're going to reduce significantly the risk of something like this that will happen. So if we'll go into the VM series a little bit, we'll start to do again. The VM series will be exactly like our hardware. You can have the EDLs, the app ID, URL filtering, the threat. Run a little bit faster here. EDLs are one of at least our favorite thing to look at when I'm utilizing our platform when I'm doing a lot of threat hunting. This is where you can dynamically add all sorts of IP and all sorts of feed off of different types of feed, especially with the cloud. And you can change, again, it changes because it's dynamic, and you can actually do some enforcement points, again, based on that.
So the EDLs and dynamic address groups, I know we're running out of time, so I'll say this quickly. Those become very, very important because as we look at security and shifting security from infrastructure to now application aware, those dynamic objects, especially in public cloud, become your friend because that's how we can support the agility that you gain from public cloud, the scale capability that you gain from public cloud, reading the metadata and being able to then associate it with security policies and posture that you've set within your devices. So as we start looking at policy as code or SecDevOps or security as code, whatever you want to call it, these become very, very critical aspects where you can actually automate the delivery of your security posture.
And again, jumping into app ID or application identification, as you can see, you can start bringing things based on app. I'll run a little bit quicker here. And you can actually utilize the app ID into your policies. So you can actually do specific enforcement policies from your firewall on specific apps and app groups. Of course, logs. Logs are everything. You can gain from here insight into logs. And based on gaining insight into logs, you can, of course, get insight into the reports as well. So as you can see, the reports are also pretty extensive and pretty important, as well as you have different levels of reports that you want to show to different types of groups, even from management, high level, or more granular. Of course, URL filtering, again, it's like on the rest of our platform. It's across the board. Even from URL filtering, you can do some control flow, as well as with the threat or the IPS. As a side note to take from here, I'm sort of really going into the admin and best practices. For me, at least, when I'm looking at logs or when I'm doing incident responses, or just for me, the HTTP codes are very, very important. They can tell me a story. And for many times, they told me the story. So not quizzing anybody, but it shows you how much data you can glean just by looking at the HTTP codes. A lot of times, things are not particularly known. There's not a particular signature, but you're looking at HTTP requests or HTTP responses. You can actually, as well, glean information if something is wrong, or if I'm doing some kind of a penetration to pen testing. I'll look at the responses and I know that there is something that is answering me over there, that there's an error over there. I can try and do some exploitation around it and some go around measures. So HTTP responses, again, just the best practices as an admin are pretty important. And of course, we use against our model of prevent, detect, and inform. I think that's pretty much it.
So I know we're down to a minute. As I said, we're happy to stand outside the back. If you guys have questions, happy to answer any of your questions that you have. Since we went a little bit long, I want to be able to give you guys a chance to ask any questions. But with the simple things of turning on logging, turning on the analytics from the platform, integrating the pieces from the native security tools to work with our devices so that we can become the enforcement points. like the HTTP code responses, that's really, really important, because as you look at an application and hardening an application, the information that you can glean from that and the ability to turn that into posture. So if somebody's profiling you and I can see that they're profiling you based on what I'm seeing from the HTTP codes, I can actually block IP addresses, blacklist IP addresses. I can do a lot of things that will help my environment that I can make dynamic based on what I'm seeing from my logs. So the analytics pieces of how we can gather that information and then use that information for security posture to help secure these public applications in your environment. Because most of you, as you see, when you turn up a device in public cloud, immediately it starts getting hit. I mean, we were doing an attack sequence for another session, and as we were running through our attack sequences, there was somebody else doing different things trying to hit our application, and you can just see it happening. You get the visibility from the logs. It's just utilizing that information to help you then turn that and secure your applications in the public cloud, which is why the visibility that we give you, that's why we, as you look at our VM series and having that inline visibility, that inline enforcement point becomes very important for your cloud environments that you're not going to get from your native tool sets in public cloud today. So thank you for your time. And as I said, we'll be in the back of the room. We're happy to stay and answer any questions. But thank you for your time.
Thank you.